So in our previous presentation, we learned the syntax of Lambda. Okay, basically it is the set of arguments and then arrow sign and code block. Okay, and every Lambda expression has to be a type of a functional interface, right? So we had to create our own functional interface. Now, Java 8 in fact provided a functional interface definitions. Okay, so for most common cases, these functional interfaces should be actually common, for most common cases, right? So Java 8 provides functional interface definitions. So there are two different kinds. One is a simply typed, the other one is a generically typed functional interfaces. We're gonna spend mostly on generically typed functional interfaces. Now we're going to actually see usage example of predicate and usage example of a function. So far we have learned basically the syntax and mechanical aspect of Lambda. In these two examples, we're going to in fact see the value proposition of Lambda, okay? And then we're gonna learn the concept of composition and the effectively final local variable. So let's actually talk about this Java provided functional interfaces. So, as I said, Java 8 comes with a set of commonly used functional interfaces in Java.util function package. So, you don't have to define your own functional interfaces yourself, okay? Because these are provided, and you might as well just use these provided functional interfaces. There are two different kinds of Java 8 provided functional interfaces. One is simply typed, and the other one is a generically typed. Okay, so simply typed function interfaces, a type is kind of built in. Generically typed, the type is not defined. Instead, it's using generic type parameter. Okay, and we'll see examples of this, both of these examples moving forward. As a developer, you still need to know the method signature of these function interfaces, meaning method name and signature of these function interfaces. So in our previous example, we have defined a calculator function interface, which contains calculate method, right? Okay, and then we were using the calculate method of the calculator interface. So same thing. So here, the function interfaces are defined, and each of these function interfaces has a method, a single method, and you're going to use this single method to execute the Lambda expression. Okay? So we'll see example of that in the following slides. So if you don't understand what I just said, don't worry about it. Okay, so let's talk about the simply typed functional interfaces first, before we talk about generically typed functional interfaces. Simply typed functional interfaces is the ones that the type of arguments and return types are predetermined. For example, we have int predicate. Basically, it's receiving int type and it returns Boolean type. And the actual method of the function interface is called test. Long predicate is receiving long type as an argument and is returning Boolean. Again, the name of the method should be the same. Long unary operator is receiving long type and returns long type. And then the actual method of that interface is apply as long. And double binary operator is receiving two double input type and returns a double. And the method of that interface is apply as double. So suppose we have long unary operator function interface, and we're going to call it the variable name operator, and this is a Lambda expression. So it's receiving a long type as input argument, and it returns long type. So that's the reason we say long unary operator. Unary meaning it will receive a single input argument. Okay. Then once you got the operator, then you can call the method of it. So in this case, the method is apply as long, and you provide the value that is going to be actually used as an argument, and it will return 20 times 10, so it will return 200 long. Okay. Int predicate is receiving int as an argument type and then returns a Boolean type, and the method of that int predicate interface is test method. So if you actually take a look at int predicate definition, the source code, you are going to see function interface annotation, and then it does have test method, and it's receiving something, and then it returns Boolean. So this is a function interface, and this is a single abstract method, right? Okay. So in order to use this definition, functional interface definition from JDK, basically you are going to provide some kind of lambda expression, and here x is in fact int type, and it returns boolean whether x is greater than 10 or not. So it will return boolean, true or false, right? And in order to use that interface, basically you're going to call the method, okay? Predicate, in this case test, and you're passing 5. So 5 is not greater than 10, so it should return false. Make sense? Okay. All right, so let's do exercise 1. So here I have imported the first exercise. Again, if you take a look at the lab documentation, let's take a look at the lab documentation of part 2. And we are doing simply type. So we're going to just do function interface simply type exercise, okay? So, I mean, this is the code. So I'm going to just use the code in the lab, simply typed. So simply, this is the one. So if you take a look at the main.java file, so this is int predicate. Okay, so again, if you take a look at the source code, you know, you can see the source code is a function interface, and it has a single method of boolean test, right? Okay. And so you provide a lambda expression. Okay, so this is the argument, single argument, so you don't have to have a parenthesis. And this is a single expression, so there is no return statement, no curly braces, no semicolon. Okay, and then we are passing 5 for test. So when you call this guy, it will actually invoke passing as 5 as x, and then it will execute this code. It should return false, right? So it should return false. So let's actually run this code. It should actually return false, the first one. And the next one is long predicate. So, I mean, we're basically providing pretty similar code, but this time, this is actually considered as a long. So when you call it, you have to provide a long value. Okay, so 20 is greater than 10, so it should return true, right? So if you run it again, so that is returning true. The next one is long unary operator. So in this case, it's actually receiving single long, and then unary operator is basically returning long type as well. So in this case, it's actually calling apply long. You are providing long value, and this should actually give you the 200, right? Okay, so let's run it again. And you can see it's returning 200. Same thing, so double binary operator. So binary operator, which means that it's passing 2 arguments, and double, meaning it's returning this guy as a double. Okay, so when you call this guy, you have to provide a double value, and then in this case, it's actually plus, so it will return 5, and that's what you have seen. If you actually kind of, multiply this guy, right, and then it's going to actually return 6, 0, right? Because that's multiplied. Okay. So for your own exercise, create double predicate function interface object and test it with appropriate test value. Create int binary operator function interface object and test it with appropriate test value. Okay. So I'm going to give you maybe a few minutes to try this exercise 1. Generically typed function interfaces. So typically you're going to use generically typed function interfaces rather than simply typed function interfaces. So these are generically typed function interfaces that are defined in Java. Supplier, type of T. Basically supplier is, it doesn't receive any arguments, but it returns something of type T. And the method, the function interface has its get. Consumer and by consumer is actually accepting something, but it doesn't return anything. Okay, so it takes the T and then return void. Okay, by consumer is taking 2 arguments rather than a single argument. So single argument is for consumer. By consumer is taking 2 arguments, type of T and U, generic type. And function is receiving some kind of argument and it returns something. So it's receiving T, type of T, and returns all. okay? And the method of function and by function is apply, okay? Predicate is an example that we have seen in our previous simply typed cases. The name of the method is test. For the case of predicate, it's receiving a single type and returns Boolean. By predicate is receiving 2 arguments and returns Boolean. Unary operator T is that it's receiving a type of T and returns type of T, and binary operator T is receiving 2 arguments, same type of T, and then it returns T. Okay, and as in the case of function and by function, it has apply method. Okay, in fact, as you're gonna see later on, unary operator and binary unary operator is in fact the extension of function and by function interfaces. Okay, so let's take a look at supply, the function interface of type generic type T. So it represents a supplier of a result. Okay, so this is a function interface whose functional method is get, and T is a type of result supplied by the supplier. So if you take a look at the definition of supplier T, you're going to see type of T and get method. Okay. And this is an example usage. So here we are creating supplier 1, which is a type of supplier string. And basically it does return string 1 or string 2 or whatever. You might in fact have some logic that generates some kind of string type. Okay, in this case we just return string 1, right? If you want to supply integer, then you're supposed to use supplier integer, and then here the actual logic should actually provide returning the integer value. In this case, we are just getting the length of a particular string. I mean, this logic on the right side could be anything that you define, right? Okay, so this is just usage examples that are using very simple example cases. So that is supplier. Supplier is basically returns some type. Okay. Okay, consumer, on the other hand, consumes something. So it will receive something, but it doesn't return anything. So return type is in fact void. And the name of the method is accept. Okay, so it represents an operation that accepts a single input argument and returns no result. So the name of the method is in this case accept, and the T is a type of input to the argument. And as I said, a by consumer is receiving 2 arguments. So this is the definition. If you take a look at the consumer definition, consumer function interface definition, this is what you're going to see. Interface consumer type of T, then it accepts that type of T argument and returns void. So this is an example. Suppose I have a consumer of string type object, which is a consumer 1, and then Lambda expression, the body of code is receiving X, which is a string type, and then we are just calling sys out println with that string value, and this println, it returns void, right? Okay. In this case, we have a consumer integer, so it's receiving some integer value, and we're going to just display multiplication, square value of that integer, and println again returns void. So this is an example of consumer. Okay, all right. You know what? Let's do supplier and consumer exercise first, and then we're gonna actually move on to function. So let's do supplier example. So if you take a look at the supplier case, Lambda function interface supplier. Okay, so let's take a look at this code. Okay, so here we have a supply of string, and the Lambda expression is basically is receiving nothing, and it returns something. That something has to be the type of string. Okay, if you're trying to actually supply like value X or something like that, that's a compile error, right? But if you take a because the supplier string, if you take a look at the supplier string, it should actually return the type of T, and the T is in this case a string, right? Okay, so if you take a look at the source code, basically, it calls a get, and then it returns a type of T. Since in our example, the T is specified as a string, we have to provide string value. Okay, so, it could be whatever string value, and that should work fine. And then, here we call the get method, and the result has to be string type. Okay, we just display it. If you create a supply of integer, then this one has to be integer type. okay, and it should return integer as a return value. Okay, so again, if you in this case trying to use some kind of string, then it's a compiler. Okay, because you define supply of integer, right? So it should be integer value, right? Okay, so for your exercise, I want you to create supplier long object with appropriate code, call functional method of the supplier, and then display result. The functional method of the supplier is what? Get, right? Okay, all right. So this is a case that we are actually calling a method, passing the supplier object as an argument. So if you take a look at the print supplier, you know, we are receiving the supplier object as a supplier type of T. And then we are calling the supplier get method here to print things out. Okay. Okay. So yeah. So for your exercise, create supplier long object with the appropriate code, call functional method of the supplier, and display the result. And create a new method called the print supplier with two suppliers, which takes two supplier object and then print them out. Okay. So that is a supplier case. Now consumer case is the other direction. So here we are going to take a look at the consumer here. So main here. So here, consumer is actually consume something. So it's receiving some kind of input argument of type, in this case string, then it will consume. In this case, it's just you know, the display things. And the println, if you take a look at the println, you know, should actually return void, right? Okay. All right. So this is the case of consumer 1, consumer 2, type of string and type of integer. And so here we are calling this consumer object directly. So you're going to actually call accept method, and you have to pass some input argument, type of, in this case, string, in this case, integer. So again, if you actually try to pass, you know, in this case, whatever, you know, different type that is, you know, the from the expected type here, then it's a compile error, right? Okay, and then this is a case that we are passing the consumer object as an argument. So consume something, if you take a look at the consume something method, it's receiving consumer type object as an argument. And then once you got the consumer object, we can call. And this is object that is actually receiving it. Okay. All right, so for your own exercise, the create a consumer object that takes the string and displays the length of it. And then call accept method of the consumer object with your name. And so this is the case that you are going to assign a consumer object into a variable. And here you're going to actually pass that consumer object to consume something method as an argument. Okay, so here you are passing that object as a type of consumer T, consumer. Okay, all right, so I'm going to let you do exercise of supplier and consumer. And I'll give you guys about, I'll give you 10 minutes. Next case is function interface. Function interface is taking input of type of T and in return something, and that return type is all in this case. And the method of the function interface is apply. Okay, so it is a function that accepts one argument and produces a result. And so T is a type of input, all is the result, type of the result. Variation by function is taking two arguments and returns returns all here. So if you take a look at the definition of function interface, you're going to see in fact T comma all, and it does have apply method, which is taking T type and then returns all. Okay, so this is an example. So here we have a function which is receiving string object and return string object. So string comma string, and the actual Lambda expression is taking X as a string, and then it's going to convert to uppercase, and then returns X. Okay. In the case of function string comma integer, so the return type is going to be integer. So example Lambda expression could be it's receiving a string object, and then the length of the string will be returned as an integer. Okay, so that is function. So function is taking one argument, or the one argument and returns something. Predicate is taking one argument and returns boolean, and again this is this function interface contains test method. Okay, so this is an example we have seen before. So in this case, example is predicate of double. In this case, Lambda expression is x is greater than 10, so it should return boolean. predicate string. So it's receiving string and it's comparing whether the length of the string is greater than 10. So this is an example of the body code. And the unary operator is basically the function interface that extends function. Okay, and it's used to work on single operand and returns same type as an operand. So in this case, the return type has to be the same as input type. Okay, so here we have a definition of unary operator T. So it's not T comma all. Instead, it's just a T. It actually has its own extra method called unary operator. Okay, but because it's extension of function of T and T, you can still use apply method. Okay, so usage example is basically unary operator 1 is basically the type, the input type and return type should be the same. Okay, so now we're gonna actually do rest of it. So we're gonna actually try with a function. So let's take a look at the function. So just kind of comment on what the Christian was talking about. Christian was not really seeing the benefit of Lambda at this point. The reason is because we have seen only the mechanical aspect of it. We haven't really seen the real practical usage of it, and that's something we're gonna actually talk about after this. Okay, so stay tuned. For now, we're gonna mostly focus on mechanics of Lambda and mechanics of function interfaces. Okay. All right, so the next one we want to do is functions. If you take a look at the function, this is a main Java. So again, it's actually receiving string type and return string type. So in this case, is the the Lambda expression is to uppercase and to lowercase. And so here we are calling the function directly. So we have a function one variable who's the type of function of string and string. And so when you call this guy, it should actually return, this one should be all upper cases. And this one should be all lower cases. Okay, that is the function 2. Here we are passing the function. So we are passing function 1 and function 2 to do something method. Okay, so it's receiving function object as an argument. And once it receives it, it just call the apply. Okay. With this value as an input. Okay. And then we also do binary function. By function is receiving 2 arguments and then return something. And in this case, we have a by function which is receiving 2 string type and return string. So in this case, we are just concatenating it. Here we are receiving 2 input arguments of string, and then it's actually returning the length, the length of the other one. Okay, so it's returning integer. Okay, so for your exercise, create a function object which takes the integer and returns square value of that integer, and call apply method of the function object using appropriate integer value. Pass the function object as do something as an argument. Okay, all right, so that is a function exercise. And then predicate. Predicate, here we are going to see predicate example. So we have a bunch of predicates. Yeah, so we have seen this example before. So create a predicate object which receives date object and returns true if the date is later than current date and time, or false otherwise. Okay. You can certainly take a look at the solution in terms of the logic of computing so you can take a look at this code in terms of how to compare the current time with the specified time. Okay, that's a predicate exercise. And the last one is function, predicate, supplier, and the unary operator. I think we have, so unary operator is here. Unary operator is basically receiving the same type and returns the same type, right? Okay. And so for your exercise, create a binary operator which takes 2 integer and result in multiplication of it, and call apply method of the binary operator passing 2 integer values, and call convert to method passing binary operator object as as an argument. Okay, so I'm going to let you do function exercise and predicate exercise and unary operator exercise. So I'm going to give you guys about 10 minutes to finish that up. And then we're going to actually go to the next exercise, next presentation, in which we're going to actually see the value of using Lambda expression, okay? As Christian was actually kind of saying, yeah, these are all mechanics of how to use Lambda, but tell me how I can use it in the practical purpose, okay? So that's something we're gonna actually talk about in the following slide. Okay, so far we have learned mechanics of Lambda expression. We have really seen the benefit or why we want to use Lambda expression or function interfaces. Okay? So the following presentation hopefully give you a sense of why Lambda expression is in fact providing some benefit. Okay, so let's see the presentation of usage example. In this case, you're going to actually see how we can use the predicate. Okay, so example scenario is something like this. From a list of object or items, find all items that meet a test criteria. So we want to use a predicate to filter out unqualified items. So this is the usage scenario. Okay, and then we have multiple options in terms of writing this code in the order of least desirable to the most desirable option. So the first example is we're going to use a for loop in Java 7. So we are not using Lambda at all. And this is the least desirable option. And then we are going to actually use a predicate with a specific type. And then we're going to use a predicate with a generic type. And the last option is in fact the stream. And this is the most desirable option. So let's take a look at each of these options. And hopefully this will give you a sense of why Lambda is in fact providing value. Okay. All right. So first, embed test code in the for loop. So this is a case that we have done in Java 7 and below version, because Java 7 and below version didn't provide the Lambda expression, right? So here, find all people whose name is John. So we have to write a method called find people by name, and then we provide the people, the list of people as the test data, and then this is the name that we are going to use as a search criteria. So, this is the simple code. We have a result array, and then we're going to be in a for loop. So we're going to go to each person in this people. And if the name of that person is the same as the name of this guy, then we are just adding that person into this result array and then return result. Pretty straightforward, right? Now, instead of actually finding all people who has a John, we like to actually also write a logic of find all people whose age is greater than 10. So we cannot use this code because this logic contains the logic of comparing names. So we have to write another method, find people by age. And we probably have to have the same logic here. And here, instead of actually using this comparison of the name, you're going to actually have a comparison of the age. Now, if you want to have another criteria, in this case, I want to find all people who has a name of John and whose age is greater than 10, then we have to write another method called the find people by name and age. And inside, you're going to have a logic of comparing the name as well as age. So you see the pattern here? Every time we have a new search criteria, we have to write a new code. And each of these code, in fact, are lots of duplication. Do you see the point? It's a duplication of the code, and you have to write a new logic, new method in this case, providing this comparison logic. So that is a bad part of this code. Every time you need to perform a search using a new criteria, new search criteria, a test criteria, you have to write a new code. Okay, so you have to write a 3 different code depending on, assuming there are 3 different test criteria. So that's not good because code duplication. Now, instead of actually doing that, we now want to actually use a predicate, okay, using Java 8, all right? So what we want to do is we want to capture the test criteria as predicate, okay? So instead of actually writing 3 different methods, we're going to actually have a single method called find people, which is receiving people as a test data, and then we are passing the search criteria logic as a predicate. So you have a predicate person, and this is the predicate argument. And basically, the criteria, the test criteria, we just call test method of the predicate, passing this person object, right? So this is a generic code, and for each test criteria, we are actually passing. So when you call find person method, we are passing different predicate. So this is a case that we are passing predicate implementation of using the name. And if you want to find all people whose age is greater than 10, then we provide a different predicate. So in this case, predicate is basically checking the person's person's age is greater than 10. And this is a case where we are passing another predicate whose name is John and whose age is greater than 10. So in this case, instead of actually writing new method, okay, we just write a single method of find people, which is receiving a predicate, and then we actually provide a different predicate. Okay, so the good part in this case is that every time you need to perform a search with a new test criteria, you just write a new predicate and pass it as an argument. So you can see this is definitely much better code than previous case. Anybody had a comment on that? Does it make sense? This is important, guys. Okay, so this is the value of using Lambda expression. Okay, give me some response, guys. I mean, this is important aspect I want you to understand. All right, nobody made a comment. Okay, so it's not that impressive. Okay. All right, now this guy still has some issues. You know, in this case, we're using predicate of person, specific type. I want to actually use the same code for, let's say, fruit or animal. In that case, I have to write a new method, like a find animal or find fruit. Okay? So instead of using specific type, now I want to use a generic type. So that is a bad part of it. The code works only with a person type and cannot be used with other type, like a fruit or animal. So the next is we are going to use now generic type. So instead of actually selecting receiving predicate of person type, we are going to receive it as a generic type of T, right? And the code is the same in this case, a predicate test and item, right? Okay. And in this case, we can certainly use this code for person, right? But we can also use this code for food and animal and whatever type. So here, the good part is the same code can be now used with a different type and person and fruit. Okay. Now, the bad part is that this code is still using for loop. Right? So the best option is using what is called the streams. That's something we're going to actually talk about in the following slide. You know, you can actually use this fluent programming style. So here I can say from a people object, I can create a stream, and then I can use a filter method, and filter will take the search criteria, you know, the test criteria. Okay. So this is something we're going to actually learn in streams, so you don't really have to worry about the this number four options. But in terms of usage of Lambda, I want you to understand this option 2 and option 3, specific type and generic type. Question: does this make sense? Quiet. All right, so let's do the exercise. So exercise is basically, we're going to actually, you know, so take a look at predicate refactoring initial method, okay? So choose Lambda fi predicate refactoring initial. And I'm going to actually demonstrate this one step by step, and then I'm going to give you guys to, you know, do the exercise yourself, okay? So if you take, so we have a person class and we have a fruit class. Both of them has fruit has a name and quantity, and then person has name and age. Okay, and so now if you take a look at the main method, okay, if you take a look at the main method, so we have a person array and the fruit array as a test data. Okay, so we have a list of people and a list of fruit. Okay, and now the option 1 is call method whose embedded test code in a for loop. Okay, so if I call find people by name, if you take a look at this code, basically we have a for loop, right? Okay. Now, if I want to find people by age, okay, then I have to write the new method. So let's actually do that. So here, so here for your exercise, write code to find people whose age is greater than 10. Observe that you have to write the brand new method that each time you need to perform a find operation with a new criteria. So here, you know, I'm going to actually list person, and here people result 2, and the find people by age. Okay, so this is not good way of doing things, right? And the age is 10 or something like that. Okay, and then I have to actually write this find people by age. Okay, so we're gonna actually create the this code. So here we have list of people and list people and the age integer. So this is age, and you know, again, we're gonna have a for loop here. Okay, so I'm gonna just copy this code. So this is the way that we used to do in Java 7, right? So this is a temp, and then yeah. So the logic here, you know, basically instead of using name, we're gonna actually use p get age and is greater than 10, right? And then we are going to display results. So I'm gonna copy this code and move this code right here. And for the sake of the display, I'm gonna call it 1. And so, you know, this is option 1, and this is the B. So in this case, when I run this code, it now displays John and John, and John and John. Yeah, so this is the age is 10. Yeah, so so the reason, yeah, so the reason is the same result is, you know, I want to actually display result 2. Okay, so F11 now it should actually display. Oh, yeah, I'm having this one again. That's interesting. I never had this kind of problem before. All right, so let's actually forget this guy for now. You know, I don't know why I'm getting this one, right? But you know, the result is the same. John and John marry. Okay, it has been working fine with this problem. But yeah, it actually gave me at least some result, right? Okay, so so this is not the way that you want to do. You know, I mean, you know, basically every time I need to have a new search criteria, I have to write a brand new method, and again, it results in code duplication. All right, so now we want to take advantage of Lambda. So that is actually for your own exercise number 2. Now we want to use call method which use a predicate with specific type. For example, predicate person and predicate fruit. Okay, so let's actually create a predicate first. Say so predicate, and you know, for using the specific type version, predicate. Okay, yeah, so let's actually import the class. It's a function predicate. Okay, so now we are specifying the you know, predicate. So in this case, you know what, yeah, let's actually write, yeah, so that's fine. You know, basically the predicate in this case is the test logic. So person, and this is the input argument, and then we have to provide the you know, true or false the logic. So person equals you have to actually get the you have to get the name, get name. Okay, the equals, and you know, the we are basically using this time John, right? So we're gonna just provide John as test data. Okay, test criteria. So we have create a predicate object, and we want to pass this predicate object to the method. In this case, the method in this case is going to be, instead of find people and find people by age, we're going to call it find people, because find people method should actually receive any kind of predicate. So you're going to actually call it so the result is going to be list of person, and so this is going to be people result. I'm going to call it 3, and then we are going to call the name of the method is find people. We haven't written this method yet. Find people, and who's going to receive the test data of people, and then we are going to actually pass the predicate like this. Okay, and you know, if everything worked fine, and it should actually provide the same result of this guy, right? Okay, and just to show you, you know, the we're actually using another predicate. So predicate, you know, the so this is, I'm going to just predicate 1 and predicate 2. Yeah, so I'm going to just copy this code and remove this line. And now we're going to actually use the age. So, you know, this case, predicate 2, and the logic in this case is get age. So get age is greater than 10 or something like that, and then so people result 4. This should be 4, and then this one predicate, this one should be 1. This one should be predicate 2. So we are basically using the same method but passing different predicate object. Does this make sense? All right, so now let's actually run, build the find people method. So we're gonna actually create a find people method. Okay, so we have a find people method, list people, and list and the predicate person and predicate 2. So here I'm gonna just call it predicate like this. And we are basically using this predicate to perform the search operation. Okay, so we can actually use the same of this guy. All right, here, and here the logic we're going to use is now here this code now can be changed with anybody want to actually how are you going to actually change this code? Predicate dot what? Test, and the object is P in this case. All right, so we have a single find people method that could be used, passing different predicate logic. In this case we are using a name, in this case we are using age. Okay, so the logic, the results are supposed to be the same. So let's actually run this code. Okay, and so we didn't display. So we have to actually display. So display result. So I'm gonna actually have this guy display result, and I'm gonna call it 2A, and the result is gonna be people result 3, and this is gonna be, now I'm going to copy this code and then move this guy here, and this is the second case 2B, and the result we are displaying is 4. All right, so let's run this code, and should be exactly the same. John and John, and John Mary, and John and John Mary. So they should have exactly the same method, right? That makes sense. Okay, and now if I want to use another the search criteria, it's just a matter of using different predicates. So for example, if I want to actually find all people, predicate 3, and the result 5, okay, and the 2C, I want to actually find all people whose names start with a J and whose age is greater than 10. All right, so here we have a people here, so I'm going to actually have the person dot get name, and dot starts with maybe start with prefix like this, and there should be J or something like this, and okay, so this is the predicate which specifies the person name start with J and the person's age is greater than 10, right? So in this case, I'm gonna just use 5, right? All right, so F11, so who that person is. Yeah, so it's John and Mary. Yeah, so they looks like the same result. Okay, so that's actually here, maybe age is 12, 17, and 13. Oh, okay, so let's actually have 15. Okay, all right, so now you should have see different result. Let's see, start with a J, John and Mary, and then so greater than 15. Oh, there should be nobody was actually greater than 15, so it should be just John. So person is predicate. Oh, so I was using so I have to use a predicate 3. Okay, so now if I run it, now there should be only a single person, John. All right, so again, the idea in this case using this predicate as an argument is I can just use a single method that can take this predicate as an argument, right? So this is much better code than previous case where we have to create a brand new method, and each of those methods has to have its own for loop, right? Okay, so this is better. Now, this is not as good as it could be, however, because we are basically now if I want to use find fruit method, if you take a look at the find people here, it can take only a person type. It doesn't take any type, right? So that's not good. So what we want to do is we want to generic method. So I'm going to actually create another method here. Okay, so I'm going to just copy this guy. And let's actually, instead of calling find people, let's say just find. Okay, and this guy should actually take any type. So instead of person, we actually change all this guy with a T. So predicate T, and this one should be T, and this one should be T, and this one should be let's see what else. Yeah, so we also have to specify the key here because this is a method, right? Okay, so that's basically it. We create a brand new generic method which is taking any type, right? Okay, so now we have a find. Now I can use the same method for not only for people but also for fruit. So now let's do that. So here, this is the case. So here I am gonna just copy this code. So here, person, yeah, so the predicate is the same. So I'm going to actually have 11 here. And so instead of using find people, I'm going to use find. And predicate is the same here. And people address, people result, I'm going to do 33 and 33. Okay. And this one should actually return the same thing, right? So if I run the code, okay, so it should, yeah, so let me just make sure this one is 3A. So that we know what we are doing. So F11, and then it actually provides the same result. So that's good. Now, the value of this one is that now I can use the same find method for passing fruit. Okay? So now, I'm going to create the predicate. So I'm going to just type in just to make sure that you guys actually kind of follow, okay, instead of copying and paste. So I have a predicate of fruit, and predicate the 55 or something, and then this time it's going to be fruit, receiving fruit as an argument. And again, I'm going to actually find, yeah, the fruit. I want to actually find a fruit whose name is apple. Okay, so it has a get name equals and apple, like this. So we have a predicate like this, and now I should be able to pass this predicate to the same find method. So I have now returned list of fruit, and this is going to be fruit result one, and then basically I'm going to use the find method, and here I'm going to pass the fruits, which is the test data, and then predicate 55. Okay, and then yeah, so then we should be able to display result. So I'm going to copy this guy and display result, and this is going to be 3B, and then result is fruit result. So I'm using the same find method. Let's see, fruit result one. Yeah, it doesn't like fruit result. Yeah, so let's take a look at the display result. If you take a look at this, yeah, display result. What is a display result? Yeah, so see, yeah, this is another for your exercise. Now I'm actually seeing display result. It's actually receiving the type of person. So that's the reason I have a compile error. I cannot use display result passing fruit, right? So this is another example where we want to genericize the the code. So here, instead of using person, I'm going to change it to T, and again I have to actually have T here because it's a static method example, and here prefix, and this is the T. Yeah, so this one should be let's see, result for each. So let's see. Yeah. So this is the case that we want to generate a display results. We got the prefix, and then we have a list of T type, and so results, and for each, yeah. So we're gonna just call it item, and then we're gonna just call it item get name or something like that. Oh, we cannot really actually use the get item method. So instead, in this case, what you do is basically use the item, and then, for person and let's say a fruit, we probably want to actually have a toString method so that they could actually display things correctly, okay? So now we are receiving, now we should be able to pass this guy, right? So let's actually see how this one works. So I'm going to press F11. Okay, so now it's actually displaying the object. So what we want to do in this case is, we probably want to do to person. So we're going to actually create the toString method. Okay, so override, and public string toString method, and then here we are going to return get name method like this. Okay, override toString public string to not this one, like this. Okay, so we're gonna actually do the same thing for fruit. Oh, we already have it. Okay, yeah, so we're gonna just do that, right? Now if I run the code, we should actually have the same thing. Oh, now 3B, why don't I actually get anything? All right, so let's actually take a look at the 3B case, whether we are in fact actually passing the fruits. So let's actually, where is the fruits? Oh, it's not, yeah, it's actually fruits. We have, oh, I see. So it's actually apple, not actually a small apple. So I should actually use capital A. All right, okay. So now if I run it, I should have apple. All right. So this is an example where we are in fact using generic type, so that we just have a single find method that can take a different type of object. Okay. So that is number 3, right? The last one is basically streams, and we haven't learned the stream yet, okay? But I'm going to just demonstrate this guy as a way of actually, this is in fact the best way of, doing things, right? So I'm going to just show this one, but you don't have to do this exercise. I want you to do the exercise 2 and 3, okay? So in this case, what I want to do is something like this. I have a people, okay? People, and I create a stream object, and then I can use what is called the filter method. Filter, you can specify the predicate. So here I can provide a filter, so I can just use this filter object here, okay? And then basically now I can actually use for each method, right? And here I can just display system.out println. Yeah, so I'm going to use the method reference like this. Okay, so let's see what happens. So I'm going to just run the code, and so you can see it's displaying John and John, right? So this is actually a lot more simplified code than what we have done before. Basically, so this is the best option, but this is something we're going to talk about later on in our presentation. Okay. Okay, so I'm going to let you do this exercise. As long as you do exercise 2 and 3, that will be good. Okay, so I'll give you guys about 15 minutes to do this exercise. And in the meantime, if you have any questions, feel free to ask. So we just take a look at an example where the predicate could be actually used to write more concise and more precise, more concise and more expressive code. Okay. Now we're going to actually do the same thing for function. Yeah, in fact, the example is actually better suited with the consumer, but let's say we're going to just use a function instead of consumer. Okay, so the scenario is like this. From a list, convert each item using conversion logic, using function to perform conversion of each item. Okay, so there are several options to write this code. Just like we have seen in the example of predicate, we could actually write the code using for loop, just like in Java 7, okay? So, this is the case. Suppose you have 1 million people, right? Again, you have to go through 1 million people, person items to actually do these things, okay? And then again, we're gonna actually do function with a specific type, function with a generic type, and lastly, we are gonna use a stream. So we are going to go through the code as we have done in the predicate, but this time we're gonna use the function. Okay, so this is the case. I want to convert name of each person to uppercase. Okay, so here I probably have to write a method called the convert people to uppercase. So in this case, I'm just converting to uppercase. Okay, okay. And now if I want to have another logic of, I want to actually convert the name of each person to lowercase, then I have to have another method called convert people to lowercase. Now, if I want to convert the name of each person to camel case, then I have to write another method. So the bad part of this coding is that every time you need to perform a new conversion logic, then you have to write a new code. And again, we are talking about duplication of code. So this is not good. So what we want to do is we want to use a function of the Java 8. Okay, so again, this is a specific type. So what we want to do is we want to write a single method called convert people type, convert people method, which is receiving a list of the people, which is a test data. Then we are going to provide a conversion logic in the form of function. Okay, so it will pass a person object and it will return person object. Okay, so this logic is receiving person, and we are going to call apply method of that function object and for each person. So when you call apply method of this function, basically this conversion logic that is specified in this as part of, as implementation of this function, the interface is going to be invoked. Okay, so here this is the actual conversion logic. So here function person, and a function one is receiving person. So we are going to get the first name. We're going to get the name of the person. We're going to convert it to uppercase, and then we're going to set the name by calling set name, and we are going to return person object. Okay, so that is a conversion logic, which is a type of this function person. And then we call convert people method with this function object. Okay, now if I want to convert the name of each person to lowercase, again, I'm going to provide this function object, okay, as an argument. So we are using the same method, convert people method. Okay. Now, if I want to convert each person to camel case, again, I'm going to provide this function object implementation and pass it as an argument. Okay. So this is the same benefit that we just talked about. The good part is that every time you need to perform a new conversion, you just have to write the new function object and pass it as an argument. Okay. And the bad part is that since we are using specific type, this code only works for person type, right? And cannot be used other types such as a fruit, right? So that is the next step. So here we are going to create the convert method, which is taking list of t type, and also function object is going to be receiving t type and return all type, okay? And then logic is pretty much generic here. Okay, so now in this case, we can pass the person object conversion, and we can also pass the fruit object. So this is the case at passing lowercase, but we also can actually pass the fruit conversion as well. So this method will be able to handle not only person type but also fruit type, animal type, whatever type. Okay. The bad part is that this is still using for loop, and so last option is, and best option is using streams. Okay, so in this case, we create a stream object from people, and then we're going to perform map operation. Map operation is basically conversion. So if you take a look at the map method, basically it's receiving function object. Okay, all right, so that's something we haven't learned yet. We haven't learned the streams yet. So we're going to actually just do exercise 2 and 3 as we have done in the predicate case. Okay, so as I did, I'm going to just demonstrate these things, and then I'll let you guys do these exercises. Okay, so let's see. Again, we're going to start with the refactoring initial, function initial here. Okay, so here we have a person, and maybe you want to actually get the fruit as well. So yeah. main here, get the fruit. Yeah, I should actually add this one to your initial as well, so that you don't have to actually do this. And then I'm going to copy, and my fruit. Okay, so we have the function initial main method. Okay, all right. So again here, call method which embed a conversion in a So this is the case that converting to uppercase, converting to lowercase. Okay, so if you run it, it's going to have all uppercase, all lowercase. Okay. The next one is here we are going to now use a function of the specific type. So here function and specific type. In this case is you're gonna actually have a person, and so let's actually import the function. Function import. Why it doesn't like this one? Oh yeah, so it's probably imported. So now I'm going to call it function 1, and it's going to be, now we're going to actually pass the function. So basically what we want to do is we want to have a person object, and then we are going to person set name. Okay, so set name method, and we're going to say person get name, and we're going to have the 2 upper case method. And now the thing is that we have to return something, right? And I cannot actually call return here, right? So in this case I have to actually have multi-line code here. Okay, so person here, and then end here, and then I have to return person. Yeah, so I mean it's actually better to actually have a consumer rather than function in this case, but since you're using function, we have to actually return the person object here. Let's see, so why it doesn't like the function. Yeah, so yeah, I'm gonna just import and then person. So now what doesn't like is syntax error insert. Oh, I didn't have let's see, so function person type person function 1 person yeah, so why it doesn't like actually syntax error insert yeah, okay, so I have to have a semicolon at the end. Okay, of course, yeah, this is actually the Java statement. Of course I have a semicolon at the end. Okay, so I have a function. So now I'm gonna actually have the convert the people method, and and then I'm gonna pass people, and I'm gonna pass the function 1 as an argument. Okay, so now I'm gonna create the convert people method. So convert people method. So here we're gonna actually see people, and this is the function 1. Okay, so let's actually delete this guy. And basically what we need to do is we are gonna actually go through the for loop, just like we did here. So we're gonna actually have, I'm gonna just copy this guy, and I'm going to move up here. And the logic here is that for each person, we are going to perform the the function 1 in this case, apply and p. Okay, so we now have conversion people method, and we should be able to call this guy, right? So let's actually run this guy. And yeah, so we convert to all lowercase. Okay. Yeah. Oh, I haven't actually displayed yet, so I'm gonna actually have the 2a. So I'm gonna say 2a and people. Okay, so let's run it, and yeah, so it's actually making as a capital. Okay. Yeah, so I don't know. I mean, it's like when I run it, sometimes it has that strange problem, but sometimes it does not. Okay, so I don't know why. But anyway, so I was able to actually get this guy uppercase. Now, if I want to convert to lowercase, again, I'm gonna just create, you know, the different function object. So here is gonna be 2b and people function. So this is gonna be function 2, and this time it's gonna be 2 lower case. Okay, all right, and so this one should be function 2, and if I run it now, it should actually have a lowercase. All right, so this is a case that we have used a function object being passed as an argument to convert people. Okay, so this is not good enough. We want to make a generic way of conversion. So here we are going to create, instead of convert people, we're going to actually have a convert, so that we can actually pass not only people object, but the fruit object as well. So instead of list person, it's going to be T. This is going to be T, and T. And then this is going to be, so in this case, instead of people, we'll say call items, and then we'll call this guy as item. Oh, I'm sorry, it's T, of course, and this is items, and this one I'm gonna just call it item, and let's pass it item like this. And now this is a method, right? So we need to have this T right here. Okay, so now we have a generic convert method which can take any type of object, in this case person object, as well as the fruit object. Okay, so now here we are going to call convert method and passing people, and we're gonna actually use the same function object. So I'm gonna just pass function 1 here like this, and then we're gonna display so this is gonna be 3a, and now we're gonna display what we can now should be able to display like a fruits, convert fruit. Okay, and do I have a fruits here? Yeah, so we have a fruits, and convert function 1. Oh, the function 1 is actually using the person and person. So I have to actually create the new function. So I probably have to have this guy copied over here, and instead of function 1, I'm going to actually function 10. Okay, and this time it's going to be fruit, and this is going to be fruit, and this is also this to be fruit, and fruit, and then function 10. Okay, so now if I run the code, now it should have, I didn't display, yes, it should be function 1, so it should be fruit, and this is going to be 3b. Okay, F11. Now it should have apple, orange, and banana, so it's all uppercases. Okay, the last one is streams. So here we are going to actually use I'm going to use fruits and streams here. Streams, and then I'm going to use a map. Basically, mapping is, you provide the logic of function. So here I can just provide this function 10, which is the mapping function, and then I can for each, and for each is receiving a consumer object, and basically I can just system.out and print ln like this. Okay, and then if I run it, then so I have this guy coming from this guy. All right, so that's the exercise. So this is pretty similar to predicate case. Now in this example, instead of actually using function, we could actually use a consumer, because basically what you do is consuming rather than returning something. You are actually returning here, right? So it could be in fact better suited by using the consumer. So I'm going to actually, convert some of this as a consumer. So here, so I'm going to actually just use, so I'm going to create the convert method. So instead of receiving a function object, I'm going to actually receive it as a consumer. So I'm going to call it and convert with consumer. I'm going to have a different method. And here I'm going to receive consumer. Consumer is actually, the taking some item, right? And so this is going to be consumer. Consumer. And so here I'm going to have consumer. And it should be, let me import. And then the method should be accept. So accept is going to be item. Okay. So consumer just consumes it and it doesn't return anything, right? So I have a consumer, using as consumer instead of the function. So I am going to use, so this is a consumer, so I'm going to take a look at the convert method somewhere. Yeah, so this is the convert method. So I'm going to actually use the, instead of the function, I'm going to use a consumer, and which is a type of T. I'm going to say consumer object, and it's going to be consume fruit, and it's going to just consume. So, basically it's going to just do this. So let's see, consumer T, I have to be specifying concrete type here. So basically, I have a consumer object that just consumes. So in this case, because we are just changing fruit object, we don't really have to return anything. So here I'm using a consumer. So here I'm going to use a convert with consumer. Yeah, so that is this method. And here I provide the fruits and then the consumer. Okay, and then I'm gonna display fruits. So here it's gonna be 3C and fruits. Okay, so let's see whether that works. F11 and 3C. Okay, so it worked. Okay, it actually had the same result. So instead of using function, I use the consumer because that's better suited, When you're using function, you have to return this guy, but we're not doing anything with the return fruit object, right? So it's probably better to use a consumer, okay? Okay, so I'm gonna give you guys about the 10 minutes to finish this up, and then we probably have another 10 or 15 minutes to finish up the rest of the presentation of this guy. I do not think we have time for streams, so I'll actually set up another code camp in the future to talk about the streams, which is very important topic. Okay. So let's move on. We have only 12 minutes and I want to finish up the two topics we have. One is composition. So what is composition? So composition allows you to apply Lambda expressions one after the other. Okay. So there are two methods. One is compose, the other one is and then. Okay. So you can pass a function object to the compose method. Okay. And so in this case, the before function is applied first, and then the calling function will be invoked. Okay, and then method is receiving function object, which is after. That means after function is applied, after calling function. So let's see an example. So this is the case that we are not using composition. So we have a function object which receive a person object and return address object. Okay, so this is a variable, a function, and here we are actually using the method reference. Okay, so it's basically getting address object of the person. Okay, in fact that is the same thing as this guy. So you get the person object and you're gonna call the get address method of the person object. Okay, so this is in fact the same thing as calling get address method of the person class. Okay. And then we have another function which is actually receiving address, and then it returns a string. So that is actually specified as address : get country. Again, that's the same thing as this guy. You get the address object, we are going to call get country method of the address. Okay, so this is the same thing as this guy. All right. Okay, so we have two separate function objects. Okay, now what we want to do is, now we are going to call person to address. So we're going to actually call person to address apply method, and we pass the person object, and this is the address. So what gets back is in fact the address object. Okay, and then once you got the address object, we can call this guy address to country function. So we're going to call apply method of address to country function and address, and then what we get back is country string object. Okay, so these are and examples where we are not using composition. We basically have a two function object, and we are calling both of them one by one. Okay, and the next one is actually being invoked with the object that was returned from the first one. Okay, now in order to use composition, add then composition, basically you are going to use this person to address function, and then you are going to call address to country function. So this is the same thing as, in this case, we are going to have a function which is receiving person object, and end result is a string object. And this is the name of the variable. Okay. And then you can call apply method with passing new person object. So this is in fact the same thing as these 4 lines of code. So theoretically, we actually reduce these 4 lines of code to 2 lines of code. Okay, you can use a composed composition. This is a reverse order. So in this case, we're going to actually use the address to country function dot compose and person to address function. Okay, so this is just a reversing it. Okay, so all these 4, I mean this part, and this part should result in the same result. Okay, and this composition, whether you're using end, then, or compose, is reducing some coding because it lets you in fact chain these functions. So that is basically what this is all about. Okay, so exercise 5, if you take a look at exercise 5, that's exactly that code. Okay, so this is the code that we are not using composition. This is using add and composition. This is a compose composition. Okay. And for your exercise, create another function called the compute length function, which returns a number of characters from a string, and apply compute length function to address to country function using end, then, and compose. Okay, so if you actually run this code, I mean, the first 3 results should be the same: country, Korea, USA, and China, because we're actually basically providing a different value, but it should work exactly the same. Okay. Let me finish up the last exercise. The last topic, and then I'm going to let you do some exercise before 4. Effectively find out local variables. What does that mean? Local variables in the enclosing body can be accessible to Lambda expression. Lambda expression cannot in fact change them, however, and they are behaving like final variables. So that's the reason effectively that's the reason it's called the effectively final local variables. So let's say an example here. So we have a calculator, the Lambda expression. So this is something that we have seen before, right? Okay. So I have a local variable, in the enclosing body. So this local variable and this Lambda expressions are in fact the same scope. So this guy can actually access this local variable, okay? However, you cannot change it, okay? So if you try to change, you can actually read the value, like in this case, you can just kind of read the values, right? But if you try to change it, you cannot do that. It's a compile error. Okay. The reason is that whatever local variables that you happen to use in the Lambda expressions, okay, is behaving like effectively final local variables. Okay. All right. So let's actually do that exercise. Effectively final local variable. Let me just demonstrate that. Here we go. Local. So here, main. So calculator is our function interface that has a calculate method, and we have a main method. And so we have a multiply method, and which is taking x and y and basically returns, so basically what it does is that just read the value 100. So it's going to multiply x and y and then multiply by 100, right? And then multiply, calculate. Yeah, so this one all should work fine. So, if I just run it, it should actually display 500,000. Okay, is that the right value? Yeah, so we actually called, yeah, so this is the actual value. Now, if I try to change this myInt, yeah, so we are using this myInt local variable, and that's perfectly fine in our Lambda expression. However, if I try to change that guy, so if I try to change it, then it's a compile error. So the compile error says that local variable myInt defined in for closing scope must be final or effectively final. So what that means is that you cannot change that local variable, right? So that is the concept of effectively local variable. Okay, so for your exercise, add integer int 200 and try to use integer body of lambda that and see what happens. Yeah, it's pretty much the same thing I just showed you. Okay, so that is the end of the part 2 lambda. Unfortunately, we do not have time for streams, and streams is very, very important concept. Okay, in fact, I would say that is probably the most important topic among the 4 topics we have in mind today. Okay, so I'm going to have another maybe 2 hours and a half or 3 hours code camp. We're gonna actually learn streams. So I'm gonna actually set that up some point in the future. Okay, all right, so let me make sure